Welcome to the session on trigonometry, grade 10 trigonometry, and today we're going to work on the Cartesian plane. So far, we've worked with right angle triangles, and therefore theta less than 90 degrees, and defined sin, cos, and tan as y over r, x over r, y over x, or otherwise opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Now, what do we do if our theta is not less than 90 degrees anymore, like this example? And one place where we might use it is to model sunrise and sunset times over a year, and we can use one day roughly as 1 degree, so 360 degrees. And for that, obviously, we will work with angles bigger than 90 degrees. And something that's important, sin, cos, and tan aren't always positive, as we have in the 90-degree triangle. So let's start with this example. Very important, we need r, and we can work it out using Pythagoras, which is r squared is x squared plus y squared, which is 9 plus 16. So r squared is 25, which means r is equal to positive or negative 5. But because r is always positive, r will be equal to 5. Now we can define sin of theta, which is y over r, which will be 4 over 5, and it's positive. Cos of theta will be equal to x minus 3 over r, which is 5, and that's negative. And then finally, tan of theta will be equal to y over x, which will be 4 over minus 3, which is again negative. Now, we will work in each of the first, second, third, and fourth quadrants, determine where each sin, cos, and tan will be positive and negative. You'll find that except for the first quadrant, in the other quadrants, there's one function that's positive and the other two that's negative. Okay, so how do we know which ones are positive and which ones are negative? There's a mnemonic that you can use, all stations to Cape Town, which means in the first quadrant, all are positive. In the second quadrant, sin is positive. Third quadrant, tan is positive. And the fourth quadrant, cos is positive. Now you can remember that, or you can understand something about sin, cos, and tan using y, x, and r. Okay. So let's look at the first two quadrants where we know sin is positive. We know sin is y over r, and in the first two quadrants, y is positive. So sin will be positive there and negative here. Let's look at cos. Cos is x over r. Now x is positive in the first and the fourth quadrant, which means cos will be positive in the first and the fourth quadrant. Finally, tan. Tan is y over x. Y and x is positive in the first quadrant, so therefore tan will be positive there. And x and y are both negative in the third quadrant, so therefore tan will be positive there. So let's go to another example, which is a bit more cryptic and closer to what you'll get in tests and exams. Say sine of alpha is equal to minus 12 over 13. Now we know what sin is y over r, so that means our y must be equal to minus 12. So if we draw this, it means this will either lie in the third or the fourth quadrant. Now we need another clue. Now the clue I'm going to give is tan of alpha is less than 0. That's all I'm saying, it's less than 0. So we can say, okay, tan alpha is less than 0. So in this quadrant, both x and y are negative, which means the ratio will be positive. So we have to be in the fourth quadrant. So alpha must be bigger than 270 degrees. So what information do we have? The y will be at minus 12 and x will be a positive number because it's in the fourth quadrant. And using Pythagoras, we will calculate that x is equal to 5. I will leave that to you. Now we can go and define some ratios. So we've got sin already, so we can work out cos of alpha, which is x over r, which will be 5 over 30. And tan of alpha will be y over x, which will be minus 12 over 5. So we have cos is positive here, which is as expected, and tan and sin are both negative. So just to rephrase, we can work on the Cartesian plane with sin, cos, and tan. Starting, the positive x-axis is our 0 and working anti-clockwise. And we know we can use sin, cos, and tan as y over r, x over r, and y over x to get our ratio. And finally use x squared plus y squared equals r squared to get whatever unknown we have. Thank you.